AQA GCSE Chemistry Foundation Tier Paper 1 Code F Thursday 17th May 2018 paper. So this is a fill in the blanks structure and some options are also given to us. So let's go to the first question. The center of the atom is the nucleus. Okay, so center of the atom, like over here, suppose this is the center of the atom and all the electrons keeps on rotating, isn't it? So we are all aware of the structure of atom as well. So this is called my nucleus, and the nucleus contains my protons and neutrons. The electrons keep on rotating and the proton and the neutrons, which forms the nucleus, are present. So for that reason, the center of the atom is called the nucleus. Now let's go to the next one. The two types of particles in the center of the atom are the proton and the, yes, so it will be my neutron. Right? Okay, so James Chadwick proved the existence of, yes, it is neutron. As we all know that James Chadwick is a very qualified, great scientist who, through his experiment, proved the existence of neutron in the atomic structure. Next comes the next question. Niels Bohr suggested particles orbit the center of the atom. Okay, so this type of particle is the, so it will be electrons. From the structure only we can see that the electrons basically orbit around the center of the atom. They keep on moving, isn't it? So this is how it keeps on moving. So basically, just a second. So as we know that there are 2 electrons in the first shell, and then it keeps on increasing by 8 and 8. So like this, it will be like. So over here, this type of particle is the electrons. Fine. And the next and the last one is the two type of particles with the same mass are the neutron and the proton. Yes, because both of them are present in the nucleus of the atom. This question is taken from AQA GCSE Chemistry Foundation Tier Paper 1 F Code Thursday 17th May 2018 paper. So a table has been given with 2 isotopes whose mass numbers are also given to us. So the mass number of the isotope 1 is 63, the percentage abundance is 70, isotope 2 is having mass number 65, percentage abundance is 30. So we have to find over here the relative atomic mass of the element X, whose isotopes are isotope 1 and 2. So the element X is having 2 isotopes. So in this case, what we have to do, we have to apply this formula to find the relative atomic mass. So isotope number 1 is having mass number 63, which we have to multiply it with the percentage of abundance, which is 70. Then we have to add this product with the mass number of isotope 2, which is 65. And then again, we have to multiply it with the percentage of abundance of the isotope 2, which is 30%. And finally, we have to divide it by 100. So after solving this, we can get the answer as 63.6 because up to 1 decimal place we have to allow it. So my answer for this question will be 63.6. Today, I will discuss another question from AQA GCSE Combined Science Trilogy, Paper Code F, Foundation Tier, Chemistry Paper 1F, Thursday, 17 May 2018 paper. Okay, so the question is about fluorine atom of fluorine. So it is having 7 electrons in the outermost shell. Okay, fine. So over here, they have showed us 2 atoms of fluorine which are present in a molecule of fluorine. Since in fluorine molecule there are 2 atoms, so we have to show only, see over here it's written clearly, we have to show only the electrons in the outermost shell and we don't have to show the inner shells. So also as instructed, we will not show the innermost shells. Since it is already given, told us that there are 7 electrons in the outermost shell, isn't it? So I would like to draw accordingly. So let's start. So I would draw 2 circles, small circles, so that I can easily just a second, student. So these are the 2 outermost shells of fluorine atom. So I will be showing only the outermost shell. So since there are 7 electrons, so I would like to draw it like this: 1, 2, 3, 4, 5, 6, and the dot structure of the another one: 2, 3, 4, 5, and 6. Now in this also I have shown 6. This also I have, in the cross structure also I have shown 6. So what about the another one? So since we know that in the outermost shells there has to be 8 electrons, isn't it? So basically over here what will happen? Sharing will take place. So now we can say that this fluorine atom is also having 8 electrons and the another fluorine atom is also having 8 electrons, and they are sharing 2 electrons. Thus, by sharing 2 electrons, both the electrons are having 8 electrons in the outermost shell. From AQA GCSE Combined Science Trilogy, Paper Code F, Foundation Tier, Chemistry Paper 1F. Question number 2.9. Explain why fluorine is a gas at room temperature. And while writing the answer, we have to use these words. So these are the key words: energy, forces, molecules, and weak. So as we know, for any gas, which is for any element which is gas in the room temperature, so the molecular force, the intermolecular force, means the force between the molecules has to be weak. If it is weak, then only with little energy, okay, it can be easily, like the forces can be easily broken. Okay, so the same logic goes for fluorine as well. So if you want to write the answer, we can write it like that. The forces between the molecules are weak, so little energy is needed to break them. For that reason, fluorine is gas at room temperature. So over here, we have used the words forces. We have also used the word molecule. We have also used the word weak. And we have also used the word energy. From AQA GCSE Combined Science Trilogy, Foundation Tier Chemistry Paper 1F, Thursday 17th May 2018 paper. The question number is 2.6. The first question is a chlorine atom is dash a bromine atom. So the correct answer is smaller than. Okay, it is smaller. So why is it smaller? This is the next question, which is, so we have to give reason for the answer of question number 2.6. Yes, so the answer will be, as we know that chlorine is having less number of electrons than that of bromine, isn't it? So since it is having less number of, since chlorine is having less number of electrons than bromine, so the radius of the bromine of the chlorine atom, the radius of the chlorine atom will definitely be smaller, isn't it? Because it is having lesser electrons, so it will be having less number of shells. For that reason, chlorine smaller radius due to less number of electrons. Thank you.